Here's how to solve messy integrals with u substitution. So here we're given a pretty complicated looking integral and we're trying to solve it. The goal of u substitution is to turn this integral into a more simple one that I already know how to solve. In this case, I know that the integral of cosine of x is just sine of x. So while I don't know what the integral of cosine of 4x cubed is, I'm just going to call this 4x cubed my u. Now what I'm going to do is implicitly derive both sides so that I get that du equals 12x squared dx. And now I'm going to solve for dx by dividing both sides by 12x squared. The next step is to replace this 4x cubed with my u and replace dx with du over 12x squared. Now if we pick the right u, we'll notice that the x squared in the du term will cancel out the other x squared in the integral. So now simplifying a bit, I get 2/3 integral of cosine u du. If at this point you haven't gotten rid of all the x's, then you didn't choose the right u. Or it means we may need to do another technique called integration by parts. Now it's important to not plug back in the u until after we've done the integral. So now that I have a simple integral, I can evaluate it and get that the integral of cosine of u is just sine of u. But since my original integral had nothing to do with u and was all in terms of x, this is where I'm going to plug back in 4x cubed for u. And now we have our answer, which is 2/3 sine of 4x cubed plus c. So now let's try to do something a little bit more difficult. So here we have a huge clusterfuck of an integral. But again, we're going to use u substitution to make this into a simple one. In this case, it can be kind of tricky to determine which thing I should choose for u. A good trick is to pick your u such that the derivative of it, du, shows up somewhere else in the integral. In this case, I'm going to choose x to the 4th plus 5 to be u, which means that du is 4x to the 3rd dx. Now solving for dx, I get du over 4x to the 3rd, and substituting u for x to the 4th plus 5, and du over 4x to the 3rd for dx, we get this. Notice again how the x cubed from the du term will cancel out with the x cubed on the top. So now my integral is a lot simpler, which is 1/4 integral of du over u to the 7th. I always like to write my integrals as straight exponents, so I'm just going to call this u to the negative 7. Now this is an easy integral that we can just use the power rule, which means we're going to raise the power by 1 and divide by that new power, which gives us 1/4 u to the negative 6 over negative 6. And now I'm going to plug back in x to the 4th plus 5 for u. So simplifying a little bit, we get our final answer, which is negative 1 over 24 times x to the 4th plus 5 to the 6th. And there you have it. That's how to use u substitution on messy integrals.
Nice!